Hello everyone, welcome to the channel CSAI Think Tinker Learn. Today we are dissecting the Redis engine. We aren't just looking at commands, we are tearing down how it handles millions of concurrent operations without breaking. We'll cover sorted sets, Atomic Lua scripting, and Sentinel high availability. Please hit the like button, subscribe, and check out my web companion site www.bitbytoken.com for full system design guides essential for anyone looking to master backend architecture. This is what the site looks like. Bitbytoken.com divided into several disciplines. Each of the discipline further has fundamentals which are searchable. Say for example you have a database, then you will get database basic, advanced and expert, and then we have sample solution, each with functional requirement, non-functional, detailed design, scalability, availability, trade-offs to be considered, and all those details are available in this. So do take a look at this and please provide your feedback so that this site can be updated to serve as a very detailed and comprehensive website for anybody looking for system designs. Coming back to our topic, let's get under the hood for Redis engine. First, let's talk about the manual scoreboard. Standard databases or basic Redis sets buckle under real-time ranking. If you try to sort a million rows in every update, you'll burn your CPU. Basic key value stores can't do range queries either. What you need for modern scale is O1 point lookups, instant range queries, and millisecond rank updates. The manual way fails, and the scalability way uses the right engine. The ZSET is not a single array, it's a dual engine. It runs a hash table and a skip list simultaneously. The hash table gives you that O1 member lookup, while the skip list enables O log and range queries. You pay a slight memory penalty for having both, but the CPU savings on your reads are absolutely massive. It's a classic, well-engineered trade-off. Why the skip list? Standard linked lists require ON linear scanning, which is total non-starter for large datasets. The skip list injects probabilistic express lanes. Level 0 is your local road for sequential reads, while level 1 through 3 are your elevated express lanes, allowing you to bypass massive chunks of data and achieve that rapid O log n traversal. Let's diagnose the window seam. Juniors often get burned using INCR or increment for rate limiting because fixed window limiters reset at the minute mark, allowing double traffic burst at the boundary. Instead, use a ZSET as a sliding window. By using timestamp as scores, you can smoothly expire old requests and ensure your rate limits are strictly enforced, no matter when the request hits. Now, the check then act chasm. Between checking a limit and adding a new request, the network can yield. Two concurrent requests can both read 99. Both see that it's under the limit and both write, resulting in a violation. Pipelines don't fix this interweaving. You need atomic operation to bridge this chasm. Enter the Atomic Lua execution chamber. Redis single-threaded nature means a Lua script executes as one uninterruptible unit. It pauses all other network traffic, making your check and act logic one single atomic motion. Think of Lua as a pause button for the rest of the world. It's the ultimate cure for concurrency bugs. How do we optimize Lua? Don't send full script every time. That wastes bandwidth and CPU. Use eval SHA. It uses a cached 40 character SHA-1 token to execute pre-compiled bytecode directly. If you ever get a no script error, your code should be smart enough to fall back to the heavy eval command. When running Lua, you control the blast radius. Use redis.call if you want the entire script to abort immediately on an error, which is often the safer default for financial or strict logic. If you need to handle the errors and keep the logic moving, use redis.pcall, which traps the error and lets the script continue gracefully. For high availability, a single Redis node is a single point of failure. Redis Sentinel provides an automatic failover, but never run just one or two sentinels. You need a minimum of three to establish a mathematical quorum, n by 2 plus 1, to prevent split brain. where different nodes think they are the primary. Failover is dangerous. So Sentinel requires proof. One Sentinel losing a connection is an S down, subjective down. It could just be local network blip. Only when the quorum is reached does it become a O down, objective down. And only then does the failover machine reactivate. Sentinel is not a silver bullet. Compare it against the Redis cluster. Sentinel is great for smaller dataset under 100 GB where you want high availability on a single primary. If you need to scale horizontally across multiple shards, cluster is the way to go, even though it adds more client-side complexity. Here is your production assembly. Scalable, race condition proof, and highly available. By layering these concepts, ZSETs, Lua, and Sentinel, you aren't just memorizing commands. You understand the architecture that keeps massive systems running. Finally, here is your system engineer blueprint. The sliding window for rate limit, express lane with skip list, and universal pause with Lua and quorum math for Sentinel. This is the core vocabulary for high-level system design interviews. What's the most complex Redis architecture you have ever had to design or debug? Let me know in the comments below. Do check out the companion website, bitbytoken.com. Again, the description will have the URL for you to navigate there. If this deep dive was valuable, and even if it wasn't, please like, share, and subscribe to support the channel. I'll see you in the next one.